Hello and welcome to the Center of Sports. I'm Diane Maloney.
And I'm Zuko. In today's special report, we're going to show you the science of sports. Some of you may think that sports just involve tossing a ball around.
But today, with Ethan Henbest, we're going to take an in-depth look at the science of sports.
Hi, my name's Ethan Henbest, and today I'm here with famous football player David Maloney to ask him a few questions. So David, what can you tell us about the science of football?
There are many equations to find out trajectory.
Thank you. Alright, so you're going to have to explain that to me a little better. What exactly is trajectory?
How far and how high the ball moves.
Oh, okay. Alright, so now explain to me, is there always a perfect or similar pattern to the flight of the football?
The ball will always travel in a perfect parabola.
Thank you for your time, Mr. Maloney.
Thank you.
And now we will continue our search for more information on the science of sports. So back here, we're on the streets of New York City with basketball player Rachel Zuko to talk more about the science of sports. So Rachel, for instance, if you were playing basketball on the streets and gust of wind blew, would it affect how high the ball went?
No, because the X and Y parts act independently.
Okay, that's kind of cool. So it wouldn't affect how high the ball went, it would just turn the ball to the left or right.
Exactly.
Ah, alright. Well, thank you for your time. Let's play some basketball. Alright, we're back now to continue our search for the science of sports with snowboarder Diane Maloney here. So far today we've been going through different sports in the world and finding out about the science of it. What can you tell us about snowboarding?
Well, you know, snowboarding's another sport that uses a lot of science in it, and you can do actually a lot of calculations to figure out trajectory and how the X and Y components act independently upon each other.
Well, we've already learned about that today, going over football and basketball. Can you tell us anything else, such as for your extreme jumping?
Well, you know, when we get close to a jump, the people who create the jumps, they create them all at different angles, and the steepness of the angle affects how high and how far you'll be able to go.
So the trajectory is affected by how the angle of the jump is. So if it's a very steep jump, how will that affect it?
Well, you get pretty high in the air, but you're not going to be able to go as far.
So that means if it's a shallow jump, you'll get very far, but not as high.
Exactly.
All right. Thank you for your time, Diane.
Thank you. That was
Go
fantastic.
land some sick jumps.
I will. That's sick!
Now for our last segment of the Sciences with Red Sox pitcher Daisuke Matsuzaka, to find out a little bit out of the science of baseball. So Daisuke, for pitching, when you pitch the ball, how do you work gravity into the equation?
Intanga humba henga ela ya benga humba henga baseball.
For air resistance, how do you work that into the equation?
Hanga humba na henga.
Okay, so you just neglect it?
Hana humba henga baseball.
Okay. Thank you for your time.
Hana humba henga.
Go lose to the Yankees. Now back to you at the studio, Diane and Rachel.
Oh, that's fantastic, Ethan. Thank you. I didn't realize there was so much science involved in the sports that take place every day.
Thank you for joining us on this special science report. I'm Rachel Zuko.
And I'm Diane Maloney.